Hi, I'm Thomas, a co-founder of Visplore. Today I'm going to show you how you can optimize your production process by comparing the operation of different equipments. This means comparing machines and other assets, but not just by some KPIs, but also really comparing the machine operation patterns, like press strokes, milling operations, or shot curves for all your different machines and plants. From this you can learn which settings lead to the best results and to the most efficient operation of your machines. The first question is usually, how do I get this type of data into Visplore? We have a separate video on that and you will find the link in the comments below. But to quickly summarize your options, you can extract the patterns directly from the raw sensor time series in Visplore, or you can import it from Python or MATLAB as nested data frames. Or you can also load them from files, where each file refers to one machine operation. This is what I'm going to show you now from the beginning to the end. So after starting Visplore, I can load my data from various sources, and in this case I will load a CSV file. This CSV file holds press stroke events from the different machines. So here you see the timestamp of the events, which machine produced it, which product it was, then some quality metrics here. And then here you see actually the link to an additional file for each pressing operation where the curve, as I showed before, is visible. And when loading this data, you can use one of Visplore's ready-made cockpits. So you don't have to set up the visualizations yourself, but in this case, the multivariate drill-down cockpit has opened without any extra setup effort. Your views are just ready. So for example, here you would immediately see the curves for all our operations. Now, what is the data about that we see here? We have 526 pressing operations. And for each pressing operation here, we see actually how the force was applied. We also see some quality metrics for each of these operations. For example, this absorption coefficient is shown here for every pressing stroke. And each point here corresponds to one pressing stroke where you see the curve here. So for example, selecting these 3 strokes here would show you the 3 corresponding curves of the pressing here on the right side. So for each operation, we don't just have the curve, but a lot of meta information as well. The different quality metrics here, absorption coefficient, but also the energy consumption, for example. Here, which machine has manufactured it. So just by hovering the machines here, you would see, for example, how the different machines have produced down here. So instead of machines, for example, we could also take a look at the different products that were manufactured here. And with one click, I would immediately see statistics for each product. Hovering the products would show me in the other views how the products looked like. So for example, product C looked quite homogeneous when I look at the curves down there. Product B, well, also more or less. But for product A, it's more interesting. Here we see 2 clusters in the data. So if I select the product A, you see the clusters down here, also with some quality thresholds. And I could easily, for example, now filter to just keep product A visible here. And now all of our visualizations are just showing the manufactured data from product A, which is actually a good basis for comparison. What do we see down here? Well, first we see a few outliers, so you can easily just select outliers and filter them out. Or here. Or also this bunch of outliers here. So this is actually something you can very easily do on the fly, get rid of all the outlier curves. But now we still see 2 distinct clusters in here. And this would be a good time to compare actually the different machines. So if we take a look here, which machines were producing product A, we actually see that machine 1 and machine 2 were producing this product. And now we could very easily enter a comparison mode to just compare these two machines. So we can select machines is what we want to compare, and machine 2 and machine 1 are the ones we want to compare. And doing this, Visplore actually compares these two machines in all plots. So it highlights them in different colors, but it also shows, for example, all the statistics here just juxtaposed for both machines. And what we see very nicely here is that the same product, remember, we're just looking at product A now, is actually produced differently by this machine and from this machine. Machine 2 is producing the same product faster. You see how the force is applied, but it ends earlier, while machine 1, the orange one, is pressing longer here. At the same time, we see here for the quality threshold that the slower producing machine number 1 in orange is closer to the set point than machine 2, which is doing it faster. Okay, so producing faster here may lead to a quality of absorption coefficient which is closer to the tolerance limit. So this is actually giving you very important information about your process, how you want to choose in this trade-off. If you want to maybe update your guidelines for pressing, if you want to optimize the speed and yield, how much you produce, or if you want to optimize the quality aspect here. And you don't just have one quality parameter here, but actually a larger number. And Visplore is actually helping you to see regarding which parameters these two different machines are different. So here you would see for all of your quality indicators how different they were for the two different machines. Okay. So looking at this absorption coefficient, you see that the machine 1 has a different value distribution than the machine 2, and that is why it's ranked to the top. It's similar for the energy consumption here. So you would see machine 2 uses less energy. And then there are some other parameters, if you look further down here, for example this one, where it's just more mixed up. Okay, so this is actually providing you a guidance if you have dozens or hundreds of parameters, settings, quality metrics, which ones are different for your compared machines. And if this is now an interesting insight here, for example, that these two machines are making the same product differently, you can easily, for example, document this as a story page and say machines 1 and 2 produce at different speed. Okay. And here you see you have made this into a first story page where you can now go on and document other insights as well. Okay, so now we have seen that these curves actually look very different when looking at it qualitatively. The question can also be, can I quantify this difference of these curves? To maybe derive some numeric features of the curves, some quantities that I can correlate with other settings maybe, or other parameters, like the costs, for example, the energy costs. And for extracting some KPIs from the curves, we actually have a ready-made tool as well. So switching here to a different cockpit for defining some properties from curves, I'm actually entering a mode where I can extract such KPIs. So here I see my curves again, and here on the left I can define which metric would I like to compute from the curves. So for example, I have a list here of different metrics I can compute from every curve as a numeric KPI. For example, the area or the integral under the curve. If I do this, then for every such curve that I have, I compute the area, so the integral of this force, as a new numeric KPI. And you see down here, this KPI is actually plotted over time. So each curve up here corresponds to one point down here. And you nicely see also that the different charges that are made here corresponding to the different machines are actually also very different in this KPI. I can compute some other metrics here. So for example, the duration for each curve that it stays above a certain threshold. This can be interesting if you want to avoid the peak pressures, the peak forces, for example. So let's define an additional KPI, duration above threshold. And here you see I can set the threshold interactively, and this updates the computation immediately. So for example, I could say every every time the force is above 10, this is actually painful. So let's set the threshold to exactly 10. And now we have computed the time here for every curve, how long this particular pressing stays above a threshold of 10 units of force. And down here you would actually nicely see also for each such batch, you see when it was, how long was my duration, which machine was this. And with these computed KPIs, we can now enter a correlation analysis where we can correlate this computed difference with actual measurements that we have for every curve. For example, how much energy was used. So let's switch to yet another predefined cockpit for correlation analysis. And entering this correlation cockpit, we actually see here how the different computed metrics, like for example our duration of the force above 10, or the different other measured things like the energy consumption, are correlated. So a red cell here would indicate a highly correlated cell. For example, if you click at these, then we would see how these metrics correlate with each other. And then if we take a look here, for example, at the energy consumption and our duration, how long this curve was above a threshold of 10, we actually see that this is very strongly correlated. Yeah? The longer the curve is above this threshold, the bigger the energy consumption of that press is. And this is also shown nicely down here, where you see the duration in orange and the energy consumption in blue, how these points actually always correspond nicely to each other. And if we want, we can actually use the color here to distinguish the machines again. So we actually really nicely see how machine 1 stays longer above this threshold and uses much more energy. Through this quantification of the difference, we can actually really correlate the different shape of the curve with something that's measurable in terms of money, the energy consumption. Okay, so this is actually emphasizing how you can save with this insight. And again, I can turn this into a story page if I want to. Correlation with energy consumption. And I've added this to my story. So maybe to summarize, we have seen how the different machines are producing the same product differently, and we were able to quantify this by extracting a KPI that we could immediately correlate with the energy consumption. And these insights we have documented as a story that I could now export as a PDF or share with some colleagues as an interactive presentation. But this is not the only way how you can compare different equipments. Let me just give you a short glimpse of how other comparison types could look like. Here we have another discrete production process with 80,000 produced items. And here you see one process parameter plotted over time. And these items were produced by different machines, which you see here, M1, M2, and so on. And in this analysis, we would compare different settings or different parameters of how to operate the machines. So for example, here we would see machine 2 was operated with two different parameters, setting 2 and setting 3. And the box plots up here show you how the value distribution of this process parameter is. Now for the same machine, we had two different settings here, and it's just one click to compare these two selections and then to see how other variables were also different for these two settings. So to learn how the different settings affected the quality of your production. And here again, you see those ranked to the top where the distribution is very different. And so you see machine setting 2, machine setting 3 leads to differences in this process parameter or in this process parameter. Some other parameters, for example, were just more similar across the different settings. But again, this helps you identify what is the impact actually of the different settings. Another aspect you can compare is the amount of scrap produced by the different machines. So here, for example, you would see again over time for each of the 5 machines how many scrap items were produced. And if you just hover the machines, you see them highlighted down there in red. And again, you could dive deep to find out why the different machines have produced more scrap than others, just using the same methods I showed before. And the final example is comparing the use of the machines. Okay, so the overall equipment use or overall equipment efficiency. For 4 machines, you see here from left to right when this machine was turned off, like in red here, for example, or it was turned on and by how much % it was actually running and producing something. So you would see here after the first 5 hours it was turned on and actually more than 90% used and not idle. You would also see this in more detail here on the right side. So this is this one machine number 4, which is shown here bigger in a higher resolution. So you would also see that the first 5 hours of that day were off. But then by showing the minutes within every hour, you would see how the patterns of being idle are distributed. So you could look at different machines here. So this one didn't have such a long period of being off. And even it had some hours where there was no consecutive period of being off or idle. And then this machine, which maybe was used the least, actually has surprisingly systematic patterns of being idle. So in this example, we actually had time series that were telling us for every time point if the machine was currently running or not. But if you don't have this kind of information, you can actually also extract this from the raw time series. Maybe you remember from the beginning of this video, if you just have the raw signals, for example, this force sensor over time, you can also extract the idle times from here. For example, by just searching for the pattern of the pressing, where you immediately get an information how much % of the data are part of an operation and how much part of the data is not. And if I select this, the idle periods, you immediately see, for example, that these periods correspond to 20 hours of being idle in total. So this kind of analysis makes your asset utilization transparent, which can be very important information for optimizing the overall equipment use. So I've showed you various ways of how you can compare your equipments in Visplore, which allows you to learn from your own operational best practices in order to reduce energy and optimize your processes. Thank you for watching this video until the end, and if you're interested to learn more, we're happy to give you a live demo.